Welcome back. In this video, we're going to finish up Chapter 7 by looking at Section 7.6, which is on quadratic equations. So this section actually has quite a bit to it, and there's kind of a big change in this section versus others in that we're dealing with equations rather than expressions, so we need to make sure that we know the difference there. And so let's get started. So big difference between this and what we've been working on so far is that we're working on equations now. Remember that an equation has an equal sign in it. An equation is a complete statement. An equation is either true or false depending on the value of the variable. And that's a big difference from working on an expression. So as you recall, an expression might be something like 2 times 3 plus 1. That's just going to evaluate to a number. In this case, it's going to equal 7. That's a big difference from an equation where we had like x plus 1 equals easy. Let's make it easy. X plus 1 equals 5. That's true if x is 4 and false if x is not 4, right? An equation has a true or false value depending on the value of the variable. An expression doesn't have that property. 7 plus 9. If I asked you, okay, is 7 plus 9 true or not? You would look at me like it was a stupid question, which it kind of is. 7 plus 9 is equal to 16, but it's not really something where you can say, yes, that's true, or no, it isn't. It's just 16. Big difference between an equation and an expression. This chapter so far, we've been dealing with expressions, how to factor expressions, turn them from a sum into a product. Our answers have been other expressions. In this section, we're working on equations, and as you remember from our earlier work with equations, when we're solving equations, we're going to typically end up with numbers for answers rather than other expressions. In this section, we're dealing with quadratic equations, and so earlier we've dealt with linear equations. A big difference here is that on a quadratic equation, the variable is squared. So unlike this x plus 1 equal 5 that we had before, which is a linear equation, all of the examples you see here have the variable squared. There's an x squared in each of these. The last one, m times m plus 2 equals 0. If you multiply the... Sorry about that. Zoom crashed on me once again. So anyways, quadratic equations have the variable squared in them. We're going to see how to solve these in a lot of detail later in this course and also in more detail in other courses. But for now, there's certain equations that we can solve by factoring and using the zero product property. The fact that we're going to factor is why this is in this chapter. So quadratic equations. Before we go on, I did want to mention one thing that can put people off a bit. When you see quad in there, often people think 4 has something to do with it. So why is the exponent 2? The reason for that is if you think about how you find the area of a square, which has 4 sides, you multiply the side lengths together, right? If you had a square of side length 10 inches by 10 inches or something, how you find the area of that 4-sided shape, you'd square 10, right? 10 squared is 100. So that's the connection between the quad part where there's 4 and the fact that you're using an exponent of 2. Okay, quadratic equations, exponent is 2. All right, so in order to do the equations in this section, we need to learn about the zero product property next. The zero product property goes like this. If you have a product of 2 numbers and it's 0, then one of the 2 numbers is 0. So here, if a and b are any numbers, if a times b is equal to 0, then it must be that a is 0 or b is 0. One of them's got to be 0. Okay, a couple of examples. Suppose that 2 times x is 0, then, well, 2 is not 0, so it must be that x is equal to 0. The important thing here is that if you multiply together 2 numbers and you get 0, one of them had to be 0. And then that's special for 0. You don't get that kind of special thing with other products. For example, suppose that you knew that v times w is 12. Well, I know that neither v nor w is 0, but if v times w was 12, would that mean that v was 6? Well, it could be, but not necessarily, right? It could be that v is 3 and w is 4. It could be that v is 24 and w is a half. right? You can't really conclude anything from there except that neither v nor w is 0. So we could say v is not 0 and w is not 0. You can't really conclude anything else about it. V could be 12 and w could be 1, right? 0 is special, right? That's why it has this property. If you multiply together two numbers and get 0, one of them is 0. All right, so we talked about this already, the difference between an equation and an expression. Remember that an expression doesn't have an equal sign and an equation does. An expression is not true or false. An equation is going to be true or false depending on the value of the variable. Okay, enough of all this. Let's do it. So here, let's say we want to solve the equation x minus 3x plus 5 equals 0. Using the zero product property, we could say, well, I've multiplied x minus 3 times x plus 5 and got 0. So then it must be that either x minus 3 is 0 or x plus 5 is 0. One of those two has to be 0 in order for the product to have come out 0. This gives us two little linear equations that we can solve. It must be that x is 3 or x equals negative 5. So there's two possible answers for this, or there are two answers for this, negative 5 and 3. You'll often find two answers or two solutions for a quadratic equation. Sometimes it will appear that there are none. Sometimes it'll appear that there is one. In the case where there's one, it's going to be what's called a repeated solution. In the case where it looks like there are none, those are going to be the kind of equation we'll have to deal with in a different class. Okay, it turns out that in reality, all quadratic equations have two solutions, but we need to learn more in order to know more about that. For now, sometimes 0, sometimes 1, often 2. Okay, here we've got 5n minus 2 times 6n minus 1. Let's call that a 1, sorry. 6n minus 1 equals 0, so it must be that either 5n minus 2 is 0 or 6n minus 1 is 0. Again, this gives us two linear equations that we can solve. So 5n equals 2, n equals 2 fifths. 6n equals 1, n equals 1/6. So our two solutions here are going to be 1/6 and 2 fifths. Notice that our answers here are numbers, not expressions. When we were working on factoring earlier in the chapter, we'd be typing in an answer that was expressions with x in it. Here, it's going to be numbers. With sets of numbers in math, frequently they're written out using these curly braces. You may see this if you're doing online homework. Frequently, the curly brace is already there for you, and you just have to type the numbers in between. So take a look at what's surrounding the answer box if you're doing this online so that you know what to type. Okay, but important thing there, we're not giving expressions with a variable for an answer. We're not going to type n equals 2 fifths or n equals 1/6, just the numbers themselves, 1/6 and 2 fifths. Okay, next up, we've got 2y times 5y plus 1 equals 0. So it must be that either 2y equals 0 or 5y plus 1 equals 0. One of those two things is true if the product is 0. So that means either y is 0 or 5y is 1, y is negative 1/5. Looks like negative 1/5 and 0 are the solutions of this quadratic equation. Okay, so we have more. Next, we have x plus 7 squared equals 0. So remember that that's a way of writing x plus 7 times x plus 7. So then it must be that x plus 7 is 0. If you want to write x plus 7 is 0 or x plus 7 is 0, you can, but it's a little repetitive. So that means that the solution is negative 7. This is an example of a repeated solution. I'd said a few minutes ago that there's often two solutions to a quadratic equation. Sometimes there's just one, or if you like, you could say there are two solutions and they're both negative 7, but usually people find that a little weird. Okay, so negative 7. Here, v minus 2 squared is 0. So that means v minus 2 times v minus 2 is 0. That means v is 2. So our solution here is going to be 2. All right, here's one where we have more work to do, and this is why these problems are in this chapter. I need to solve x squared minus x minus 12 is 0, and it's not factored like these earlier examples were. So this is the part where you get to practice your factoring. So this time, no common factor. There are 3 terms. It's not a perfect square. I'm looking for 2 numbers that multiply to negative 12 and add to negative 1. One will be positive, one will be negative. It looks like negative 4 and positive 3. Okay, and so that means that either x plus 3 is 0 or x minus 4 is 0. So that x could be negative 3 or x could be 4. Okay, important thing to note here, our solutions were negative 3 and 4. Notice that that's not the same as the 2 numbers you were looking for when you were factoring. When you were factoring, you thought, okay, well, I need to find 2 numbers that multiply to negative 12 and add to negative 1. That was negative 4 and positive 3. And that helped us factor this thing. But that ended up being the opposites of what the actual solutions are. Actual solutions are negative 3 and positive 4. Okay, let's try this again. So now we've got 2y squared equals 13y plus 45. So what I would do first is collect all the terms onto one side. If we're going to use the zero product property, I have to have it set equal to 0, right? So I've subtracted 13y from both sides. I've also subtracted the 45. Okay, so now there's no common factor. It's 3 terms. It's clearly not a perfect square trinomial, so I'm going to need to factor this thing using either trial and error or the PQ grouping method, which I think is easier, so I'm going to do that. I need to find 2 numbers that multiply to be the same as 2 times negative 45, that's negative 90, and have to add up to negative 13. Okay, so we need to multiply 2 numbers, getting negative 90, like 9 times 10 or 45 times 2. And we need to rig it so that they add up to negative 13. Since their product is negative, they have to differ in sign. And since their sum is negative, the one with the bigger absolute value will be the negative 1. So ways of factoring 90. So 90 is 45 times 2. 45 is 9 times 5. 9 is 3 times 3. So we could have 15 times 6. That doesn't do it. We could have 10 and 9. What else could we have? 18 and 5. Looks like negative 18 and positive 5. Okay, so now we'll factor by grouping. 2y squared minus 18y plus 5y minus 45 is 0. Okay, now we're factoring by grouping. First 2 terms have a common factor of 2y. That will leave us y minus 9. And then we'll have 5, again, y minus 9. Y minus 9 comes out, leaving 2y plus 5. Okay, so we're finally ready to solve. So we could say either y minus 9 is 0 or 2y plus 5 is 0. That means that maybe y is 9 or y is negative 5 halves. Okay, so our 2 solutions, negative 5 halves. And so this one, it took us a while to get the factoring done, but we did it. Okay. So remember that our answers here are just the 2 numbers, not the factorization of the left side of the equation. All right, here is one for you to try. So take a minute and pause the video, restart the video, and see how you did. All right, so we have 6a squared plus 9a equals 3a. So I'm going to first subtract 3a from both sides. So that sets it equal to 0 and simplifies things some. So we have 6a squared plus 6a equals 0. Let me factor out the 6a. That will leave a plus 1 in the parentheses. So then here it must be that 6a is 0 or a plus 1 is 0. If 6a is 0, then a is 0. If a plus 1 is 0, then a is equal to negative 1. Our two solutions are negative 1 and 0. Okay. All right, so this one looks fun. We have 25x squared equals 49. So let's collect that 49 to the left side. And so we'll have 25x squared minus 49 is 0. No common factors on the left side, but it should look to you like it's a difference of squares. That will be 5x squared minus 7 squared. So when we go to factor it, we'll have 5x plus 7, 5x minus 7 equals 0. So then it must be that 5x plus 7 is 0, or 5x minus 7 is 0. Solving each of these for x, we'll get negative 7/5 for the first one, and 7/5 for the other one. So negative 7/5 and positive 7/5. Okay, there's our two solutions. Okay, so here we're using factoring as a tool to help us solve some equations. So we're going to keep trying, and eventually we'll get to some word problems, which will be some fun. Okay. All right, so here, this one's pretty neat. We've got 2m plus 1 times m plus 3 equals 12m. For this one, you want to be real careful. It's very tempting to say, okay, I know how to do this. 2m plus 1 is 0, m plus 3 is 0, and so on. But I can't do that because remember that the zero product property says if you've got two things, you multiply them and they equal 0, then you can say something about them. But here on the right side, I don't have 0. I've got 12m. So what we're going to need to do first is actually multiply everything out on the left side and collect that 12m onto the other side and refactor. That sounds like a lot, but we can do it. So let's first multiply out the left side. This will be 2m squared plus 6m plus m plus 3. On the right side, I still have 12m. There's 2m squared plus 7m plus 3. That's equal to 12m. Collect the 12 onto the left side. That's 2m squared. Subtracting 12, 7 minus 12 is negative 5. So we'll have negative 5m plus 3. Now it's equal to 0. So we've succeeded in getting this thing set equal to 0. The left side, though, we still need to factor. So I'm going to factor that by grouping. So I need two numbers that multiply to 6 and add to negative 5. So that would be negative 2 and negative 3. So we'll split that negative 5m into negative 2m minus 3m. Okay, then continuing to factor by grouping, common factor of 2m in the first two terms and negative 3 in the second two terms. So factoring out that m minus 1, we'll have 2m minus 3 left behind. Okay, so now we're almost done actually. We'll have m minus 1 equals 0, or 2m minus 3 equals 0. That means that m has to be 1 or m has to be 3/2. So 1, 3/2 are our two solutions. Okay, so I know this was more work than just setting the two things equal to 0, but that would have given us the wrong answer, and we don't want to do that. Okay, so important thing, when you're using the zero product property, you have to have the thing set equal to 0, not set equal to 12m. Okay, here's one for you to try. Pause the video, try this one yourself, restart the video, and see how you did. All right, so while you're working on that, I first collected all the terms onto one side. I subtracted 24x squared and 18x. I added actually to both sides, so we have that set equal to 0. Then I thought, well, now we have a common factor of 2x, so let's factor that out. So factoring this out, we've got 2x, and then what's left? 4x squared minus 12x plus 9. So that's a perfect square, right? So let's make it look like one. That would be 2x squared in the front, and 3 squared in the back. In the middle, make that a little bigger. In the middle, we should have 2, and then there's minus 2 times 2x times 3. And finally, the 3 squared in the back. So that's going to be a perfect square. We'll have 2x and 2x plus 3 squared. Okay, so then this gives us 2x equals 0, or 2x plus 3 equals 0. I don't need parentheses on there, really. So 0 or negative 3 halves are our solutions. The negative 3 halves is actually a repeated solution because of the fact that 2x plus 3 was squared in here. All right, so that takes us to most of it. I did want to mention one kind of commonly occurring mistake with equations like this, just so that you're less likely to make it. So let me read the equation. We have 8x cubed equals 24x squared minus 18x. One thing I see people do is say, okay, well, I see there's a common factor of x here, so let's just divide both sides by x, and that'll kind of quote unquote simplify things. So this would give us 8x squared equals 24x minus 18. So that you can do, and it will give you some of the solutions, but you are going to lose the solution of 0. And the reason why you won't get that one when doing this is that in dividing by x here, you remember that 0, you can't divide by 0. So when you've divided by x in this step, then you lose that 0 solution. So in general, you want to be very careful dividing an equation by expressions containing the variable. It's safest to factor. Okay. All right, so we're almost done with this section. The last couple things is we want to see some story problems that we can use quadratic equations to help us solve. So let's try these two. It says the product of two consecutive integers is 240. Let's find the integer. So we're trying to find two numbers. We are going to do this using only one variable, though. The fact that the two integers are consecutive means that we can always express one in terms of the other. I'm going to let n be the smaller one. Okay? Always a good idea to define your variable. So if n is the smaller one and they're consecutive, n plus 1 has to be the bigger one. Okay, and so we're told that the product is 240. So that means that n times n plus 1 has to be 2. Right, so there's our quadratic equation. We're going to solve that as we've done before by multiplying, get everything set equal to 0 and factoring, right? So we'll have n squared plus n is 240. N squared plus n minus 240, 0. So this thing is a trinomial. There are no common factors. The leading coefficient is 1, so we should be able to factor this thing without too much trouble. Difficulty is trying to find two numbers that multiply to negative 240 and add up to 1. They differ in sign. And so we're going to have 1 plus and 1 minus. So we need to think about ways of factoring 240, and we need to make it so that the two numbers we're looking for have to be they're opposite in sign, and so their sum ends up only being positive 1, so they have to be fairly close together. what I mean by that is this. 240 is 24 times 10, but negative 24 and 10, that adds up to negative 14. So we need those two numbers to be closer together. So let's take a look. All right, so after you work on that for a little while, you'll end up getting 15 and 16. So the sum has to be positive, so it'll be positive 16, negative 15. So our solutions there are going to be n plus 16 equals 0, or n minus 15 equals 0. So negative 16 and 15. And notice that those aren't the two numbers. Remember, n had to be the smaller one. And so we have to find out what the next one up will be. So negative 16 and negative 15 would be one pair of numbers. Those two should multiply to positive 240. And then 15 and 16 will also multiply to be 40. So for this one, there's two possible solutions of two numbers each. Negative 16 times negative 15 will be 240, and 15 times 16 will also be 240. Okay. Let's try next one that has a little bit of geometry to it, not too much, just a little. Here it says a rectangular patio has an area of 180 square feet. We're told that the width is 3 feet less than the length. We want to find the length and width of the patio. So anytime you're doing something with kind of a geometric feel to it, it's a good idea to make a picture. So I'm going to do that. We want to find the length and width. That's two things. I'm going to do this using only one variable, though. The width is described in terms of the length. So I'm going to make the variable be the length. So L will stand for the length. And then the width is 3 feet less than that. So width will be the length minus 3. So we have the length and the length minus 3 for the width. Okay, so if it disturbs you how I labeled this, maybe you wanted this turned, a quarter turn, whichever one you want to consider the length, the width is the other one, right? So if you like, turn your computer a quarter turn. Okay, so there's our rectangle. We know that the area is 180 square feet. So the area of a rectangle is the length times the width. So we'll have L times L minus 3. That's equal to 180. Okay, and so that gives us our quadratic equation that we can solve. So we'll have L squared minus 3L equals 180. And we'll collect the 180 to the left side, giving us L squared minus 3L minus 180 equals 0. So once again, we're in the position where we need to factor. And so we need to find two numbers of differing signs. And we need to make them so that their product is negative 180 and their sum is 3. So I think it's going to be 15 and 12, but let's see. Yeah, 15 and 12, actually. I got lucky at that time. So it's negative 3, so that'll be negative 15 and positive 12 for that. So it looks like the length is, or L plus 12 is going to be 0. So L equals negative 12. L minus 15 is 0, so L is equal to 15. So here the length, unlike the one with the consecutive integers, this one has kind of a real-life interpretation to it. We don't use negative numbers to represent lengths, so this one is not going to lead us to a solution, L equaling negative 12. The L equaling 15 is the one that we want, so the length has to be 15. And the width is 3 less than that, and so it has to be 12. Okay, so for distances and lengths, those are always measured in positive numbers. And so if you're doing a problem like this and you get like the width of the pool is negative 7 feet or something like that, it's not going to be a solution. It's only going to be the positive solutions you're looking for. Okay, and so we end up with 15 for the length on this, 15 feet for the length and 12 feet for the width. By the way, if you're doing this on like a computer homework or something, make sure that, if it's asking you for the length and the width, you're supposed to type these into a box. Make sure to put the right number in the right box. Otherwise, you get it wrong for no real reason. Also, if you're doing this on paper, make sure that you label them correctly as far as which dimension is which. Okay, so we have just one more and then we're all done, I promise. This one is about a sail on a boat. It says a boat sail is a right triangle. The length of one side of the sail is 7 feet more than the other side. The hypotenuse, that's the long side, is 13. We want to find the lengths of the two sides. Okay, so here it says the length of one side is 7 feet more than the other side. So I'm going to let x be the other side, just because I think that's going to be easiest. And then what the problem is referring to as the one side is 7 feet more than the other side. So where the other side is x, the one side will be x plus 7. So we have x plus 7, and then the hypotenuse 13. So we've taken everything we can out of the wording of the problem. The piece that we don't have is the Pythagorean theorem, which you may or may not remember. Hopefully you do. Pythagorean theorem. Okay, and so the Pythagorean theorem tells us that if you have a right triangle with sides of length a and b and hypotenuse c, that a squared plus b squared equals c squared. The kind of typical first example of the Pythagorean theorem is the 3, 4, 5 right triangle, right? 3 squared plus 4 squared is 9 plus 16. That's 25, which is 5 squared. If you need to know more on the Pythagorean theorem, you can take a look on Google or YouTube for it. It turns out that that's what we need for this problem. We'll have x squared plus x plus 7 squared equals 13 squared. The sum of the squares of the two side lengths equals the square of the hypotenuse. Okay, so if you're caught up, that gives us the quadratic equation, which we can now solve. Fortunately with this, we can forget the context kind of at this point. You don't need to try to juggle all these thoughts in your mind all at once. Once we've set up the equation, we can kind of temporarily forget where it came from and just solve it and then get back to its meaning at the end. Okay, multiplying to clear parentheses out. (13 squared is 169. Okay, so then in the middle, x plus 7 squared, that was a perfect square, so I multiplied that out. We'll have 2x squared, 14x plus 49 minus the 169 equals 0. And then this will give us 2x squared, 14x, and then 40 minus 160 is negative 120. All right, so there's that. And now common factor. All right, so I took out the 2, so that helped a little bit. Now we need to factor the quadratic that is inside. We're looking for two numbers that multiply to negative 60 and add to 7. So I'm thinking that's going to be 12 and negative 5. Okay, and so that will do it. So then 2 is not 0, so it must be that either x plus 12 is 0 or x minus 5 is 0. Again, if x plus 12 is 0, x is negative 12. If x minus 5 is 0, x is 5. So as I'd mentioned before, this is a length of a side of a triangle, and so it's not going to be negative 12. So that x equaling negative 12 is not going to give us a solution. However, the 5 does. So we know this, now we're back to the meaning of the problem. So we know that what I've labeled as the other side is 5. The one side is 7 more. 5 plus 7 is 12. So the question is asking us for the lengths of the two sides. So the sides are 5 and 12. Okay, and then the hypotenuse was 13. All right, so that takes us to the end of this section and actually the end of this chapter. As we saw, working with quadratic equations takes some care. We can use the tools we learned in this factoring chapter to help us solve quadratic equations. We saw that we can do a couple of story problems involving those. A natural question is, what do you do if you can't factor the polynomial? And that's where kind of the work in later in this course or in other courses will come in. But for cases where you can factor it, it's a good tool to help you solve a quadratic equation. All right, so that takes us to the end of this section and this chapter. Let me know if you have any questions, and have a great day.